Okay, so have your notes out. We're going to get started simplifying and proving part 3. And on this part here, there's no new trig identity that I need to give you. We're just going to look at more difficult problems in nature. Just work through some difficult problems together. And I'll point out a couple strategies as we look at these difficult problems. And this is like I said, the last level of difficulty, and so it does not get any more difficult than this. And so let's jump into number 1 here. So it says simplify sine cubed x times cosine of x plus sine x times cosine cubed of x. You even had one like this in the quiz you just took, maybe a little easier than this one, but something similar. And you've had stuff like this on your homework before. What's the first move on this problem? Factor. Okay, and that's what I want to bring out. Just we have 2 terms here. Okay. Everything's in terms of sine and cosine already, so putting it in sine and cosine is not going to help us. But notice each term has a sine and has a cosine. And so that's what I'm going to factor out of both. I'm going to factor 1 sine of x and 1 cosine of x out of each of those 2 terms. So when I factored it out of the first term, what's going to be left? Sine squared x. And when I factor sine and cosine out of the second term, what's left? Cosine squared. And so sometimes when you factor, your result is going to be something that you're going to be able to simplify. In this case, we have sine squared plus cosine squared, which is equivalent to 1. And so this becomes sine of x times cosine of x times 1, which is just sine of x times cosine of x. And that's all we're able to do on this one. Okay. Let's look at another one. Number 2. Simplify 2 times sine squared x plus 2 sine squared x cotangent squared x. Go ahead and write that down. Okay. So we saw in example 1 that factoring helped us out, and we're just going to practice that factoring a little bit more. And so again, here we have, how many terms are there? Terms are separated by plus signs or minus signs, and they're held together by multiplication. So we only have 2 terms. If you look at those 2 terms, what would the greatest common factor be? A 2 and a sine squared x. So we're going to factor out the greatest common factor. And when you factor that out of the first term, what's left? 1. Make sure you put the 1 there. Plus, when you factor it out of the second term, what's left? Cotangent squared x. Okay. So then we're thinking, okay, we got that cotangent squared. When you see the squared, you should be thinking through, do we know a trig identity or a Pythagorean identity that works with this? And we do. What's it equal to? Cosecant squared x. And so that's one of the things we memorize, that 1 plus cotangent squared x is equal to cosecant squared x. And if you get confused, like on these, like, does cotangent go with secant or cosecant? Think about if you were to change those in terms of sine and cosine, what would the denominators be? And they need to match. So in both cases, the denominator would be sine. That's why they go together. And same with tangent and secant, they would go together because of that. So we're going to change this to 2 times the sine squared x times the cosecant squared x. And is there anything else we can do? Okay, well, distributes when we have addition, so there's no more addition or subtraction, but multiply, right? And what is sine squared times cosecant squared? 1. They're reciprocals of each other. And so this is just going to be 2 times 1, which is 2. So it does simplify quite a bit. All right, next one, I have a proof for you to try. Prove that tangent x plus tangent cubed x is equal to sine x times secant cubed x. And remember, when you're proving, you can only change the left side of the equation. You've got to leave the right side of the equation alone. So try to change the left side and make it look like the right side. I'll give you a few minutes to try this one. So, any tips for the first step? Yes. All right, factor tangent x out of the first two terms, and you should get 1 plus tangent squared x. Okay, so that's a good first step. And then that 1 plus tangent squared x becomes secant squared x. So that's the way to start. Now, we need to make the left side still look like the right side. But now we have, what we did in doing this, we went from 2 terms to 1 term. So now we're down to 1 term, and that's what we want. What would be another good tip? What would you guys do next? Okay, so you change tangent to sine over cosine. Did you leave secant alone, or you change that? Change that as well? Okay, so we're going to change that to 1 over cosine squared. Okay. That works. So move the denominator up to the top by writing its reciprocal function, which is the secant cubed x. And that is perfectly fine. We made it, and it works. There are other ways to get there too, but that works. Okay. Any question on that one? All right, so these first 3 problems were just illustrating that factoring can be helpful. Okay, the next 4 problems are going to be illustrating that, well, sometimes you want to go the other direction. Sometimes you want to multiply to actually simplify. So here's number 4. And these we have not done yet. I haven't asked you to multiply trig functions yet, but it's just like multiplying anything else. So we got the cosecant x minus cotangent x times the cosecant x plus the cotangent x. So question, can I use Pythagorean identities right now? No, why not? Nothing is squared. Okay, you have to have the squared to use the Pythagorean identities. So nothing's squared yet. But if I multiply stuff together, it might become squared, right? So then I'm going to try multiplying. So cosecant times cosecant is cosecant squared. Cosecant times cotangent is cosecant, oops, not cosine. Let me fix that. Cosecant x times cotangent x. negative cotangent x times cosecant x is going to be negative cotangent x, cosecant x. And negative cotangent times positive cotangent is negative cotangent squared x. So you just distribute and multiply that out. You end up with how many terms? How many? Well, right now, how many do I have? 4, but it's going to change, right? Remember, terms are separated by plus and minus signs. But right now, you see 4 terms. But can you explain how we get 2 terms out of that? Okay, so the second and the third term are like terms, although the products are in opposite order, right? You got cosecant times cotangent, but that's the same thing as cotangent times cosecant. One's positive, one's negative, and so you can combine those like terms, and you end up with 0. And so you're just left with cosecant squared x minus cotangent squared x. And now you should be thinking, okay, Pythagorean identities. There's one going to work here for us. And we know that the cotangent squared plus 1 is cosecant squared. So can we change that to make it cosecant squared minus cotangent squared? And if we do, what's it going to be equal to? 1. And so that simplifies kind of nicely for us. Just a 1. So here's a case where multiplying had to happen in order to simplify. Okay. All right, try this proof. And the first two people to show me a good proof. Got some candy I'm trying to get rid of here, so to choose here. I'm just showing the multiplication. But keep going. I want to know when you get the answer. When you have the proof that works. Make the left side look like the right side. All right. Any advice from you guys? Some of you went further. I know you did. And so what's your advice? What should we do? Yeah. Okay. So we have a tangent squared here. And we have a plus 1. If we rearrange it, put those together. And then these two middle ones we can add to 2 tangent x. And then this piece, like you said, is the secant squared x plus 2 tangent x. And you're almost there. And so that would be 1 over cosine squared x plus 2 sine x over cosine x, right? You get that far? Yeah, finish. What do we do next? You're like right there. How do you go from 2 fractions to 1 fraction, guys? How do you add fractions? You need a common denominator. So this is cosine squared, this is cosine, so what do we need here? Cosine over cosine. You seeing it yet? And so when you add those, the top becomes 1 plus 2 sine x, cosine x, and the denominator stays the same, cosine squared x, and we did it. You guys are getting close, right? You guys are getting close. Okay. Any question on that one? All right. I have 2 more to do, and I got, again, candy to give away. This next one I'll give candy to up to 4 people. All right? Up to 4. Oh, why do I have an answer already? Hold on. I don't know why I have writing on this one, so let me, do not want to show you that. And actually, this next one might feel a bit easier than number 5. So here it is, number 6. You guys can do it. First of all, the angle here is another Greek letter that I haven't introduced to you, but I'm glad it didn't affect you. A lot of, you just went on and said, oh, it's just an angle, right? So in terms of Greek letters, trigonometry, we introduced quite a few in trigonometry, even more when you get to statistics. But what are some Greek letters that we know already? Theta, right? We got theta, which looks something like that. This one right here, anybody know what this one's called? Beta. Some of you know beta, right? Oh, it's on the board. I know. You might see alpha eventually. You guys know pi. I put that on the right. So you guys are learning some Greek here. All right. So the proof here. So we got tangent beta plus cotangent beta, and it's squared. So I'm gonna put another tangent beta plus cotangent beta, and now I need your help. Okay. What is tangent times tangent? Tangent squared. What is tangent times cotangent? 1. Good. Cotangent times tangent? 1. Cotangent times cotangent? Cotangent squared, beta. And what is tangent squared plus 1? Secant squared. And what is 1 plus cotangent? Cosecant squared. All right. All right. You guys got this stuff. This is as hard as it gets, though. All right. We're at the. I raised it to the max difficulty level right now. Okay. We got one last one. Again, can have up to 4 winners. This one does have a little bit of work. Okay. I have a word of advice for you as you do this one. Okay. Well, 2 words of advice. First of all, what's sine plus cosine? No. What's sine plus cosine? I don't know either. Okay. So don't make that one. Okay. It's not sine squared plus cosine squared. Don't make that one. That's my first word of advice. Second thing. So you're obviously going to square this. You're going to square the sines minus cosine as well. But notice there is a minus sign in between. And you need to just, my word of advice is square this piece, leave that minus sign out of it, and put whatever you have here, whatever you end up getting when you square it, put it in parentheses or brackets, and then distribute that negative to everything. Otherwise, things can go bad. Okay, so that's my advice. Other than that, you guys can do it. You do get a long string of things, right? When you multiply this out, I just need to keep track of stuff. So we got the sine beta plus cosine beta times sine. You just got two of these, right? And then minus, you got sine beta minus cosine beta. Two of those. And then just carefully multiply stuff out. So sine times sine is sine squared. Sine times cosine. Cosine times sine is another sine beta cosine beta. And then cosine times cosine is cosine squared beta. And I'm just going to work with this piece. Notice that there's a sine squared plus a cosine squared, right, which is 1. And then these two middle terms are alike, so I could write plus 2 sine beta cosine beta. Okay, so that's the left side. Minus, now I'm gonna put that right side in brackets. Okay, so sine times sine is sine squared minus sine cosine minus another sine cosine plus cosine squared. And then I'm going to leave minus, I'm going to leave the brackets, but we're going to do the same thing. We got sine plus cosine, which is 1. And then these are like terms, and they're both negative, so minus 2 sine beta cosine beta. So we're getting less stuff here, right? Now I'm going to distribute that minus sign. When I distribute, I get 1. I'm going to repeat this part. And I'm hoping that you're comparing this with your work to see maybe how far you made it, right? And then the 1 minus 1 is 0, and we can combine these and get 4 sine beta cosine beta. Now we've gone from lots of terms, 8 terms, down to 1, which is nice. This is a fraction, and now let's bring these two to the bottom of the fraction, and we win. We bring it down because we're trying to match what it was, right? So there's a bit of work, yes, but we had some people make it. That's good. All right, so you have the remainder of the period to work on your homework, which is the next 2 pages. I'll leave this up there if you want to compare your work.